All right, have your textbooks out. Open to page 407. Page 407. Tomorrow we're going to be reviewing for your test. We're going to wrap stuff up today as far as our algebra stuff is concerned. We'll do more algebra after this test, but your test on Wednesday coming up in lesson 163 is going to be all things graphing. Your bar graphs, your stacked bar graphs, your circle graphs, your histograms, your line graphs, all that stuff like that there. All the terminology like the chart title and the scale and the labels and the axis titles and the major grid lines and the minor grid lines and the legend, lots of terminology to know. Things like that. Okay, all that graphing stuff, you've all taken quizzes over it at this point. We're going to review over it some more tomorrow. That'll be on the test Wednesday. And then what we've been working on, and then what we're going to work on today will be on the test Wednesday. But let's start by looking at page 407 and the review section, unit numbers 43 to 59. 43 to 59 in the review section. Excelente, excelente. Bueno, si, da. All right, let's take a look at this together. Number 43. You're supposed to evaluate the expression if P is 7 and Q is 11. What did you get, Kirsten?
I got 40.
40 is correct. Very good. Number 44. You're supposed to evaluate that expression if A is a 12 and B is a -4. What did you get, Jalen?
-8.
-8 is correct. How many got both of them correct? How many got them both right? How many got one of them right? You got one, missed one. Anyone missed both and need to see them worked? Let's take a look. Remember, the key is to just plug in the numbers. So it says P squared, well that's 7 squared, plus 5P, well that's 5 times 7, minus 4Q, well that's 4 times 11. What is 7 squared, class? 49, and then 5 times 7,
35.
and then -4 times 11,
-44.
-44. We'll combine these to get, is that an 84? And then positive 84, -44 is positive 40 for our answer. Looking at number 44, we had a -A, which is 12, times B, which is -4. Positive 5, and then B is a -4, and then -3, and then A is a 12. Well, here, what is 12 times -4, class? -48, but then we've got this other negative as well. So -48 would be positive 48. Or you could just think of this as a -12 times -4 is positive 48. So a couple different ways to think of that. Then right here, positive 5 times -4, -20. And then -3 times 12 is -36. I'm going to combine the two negatives first to get a -56. And then when I subtract, keep the sign of the greater, that's where we get -8. Look at number 45, simplifying the pollen question.
I had -48, but I still got -8.
Then something went wrong. So it should have been a positive 48 right there. Does that make sense? Well, does it or doesn't it? Yes or no? I mean, so -48, right? This is basically minus a -48, so we add the inverse, hence positive 48. Or if you think of this as negative times negative, it's positive 48. Two negatives make a positive. We're going to look at that again today, so we'll
Yeah,
get you.
positive about that, man.
Yes, exactly. Okay, Griffin. It's a Monday. All right, number 45, combining like terms. Elaine, what you got?
2ln.
How about a 21N?
Yeah.
21N. How about number 46? Luciana.
5y.
Positive 5y. Number 47, Corey.
13k squared.
13k squared. Number 48, Bryson. Sorry?
11P.
11p is correct. Number 49, Griffin.
12G squared.
Okay, careful here, Griffin. We got the 13g squared, and it says -12g or -2g squared, and then -g squared. What number is technically in front of this g squared?
1.
A -1. Combine the two negatives first. -2 and -1 more would be -3g squared. Now when we combine, we end up with a
10G
a
squared.
10g squared. Or if you just went in order, 13 -2 is 11. 11 -1 is 10g squared. Number 50. What you got here, Joel?
6a positive 7b.
6a positive 7b. Again, only the b terms combine. The 6a has no friends, but we still keep it at the front, so we keep it in alphabetical order. Number 51, Michael.
5. 15 r squared plus 6 r plus 6r plus 1.
15r squared, positive 6r, positive 1 is correct. Number 52, what did you get, Ben?
9 and negative 4z.
Okay, so let's take a look at this here, Ben. There's a 9w at the beginning, and then later on there's a negative w. What number technically is in front of that negative w at the end?
1.
Negative 1. I think you looked at it as a 0. Like 9w minus nothing is 9. No, it's 9 minus 1 would be 8w. And then here you saw the negative 4z and the positive 8z. And you're right, we're going to subtract because the signs are different. 8 minus 4 is 4, but we keep the sign of the greater. Which is the winner, the negative or the positive here?
Positive.
The positive. So we're going to say 8w positive 4z should have been our answer. How about number 53? Let's come back to you for redemption on that one.
3b and 9b.
Well, let me write out the original problem here, Ben. We got a 3b cubed, positive 4b squared, negative 9b, positive b cubed. Again, one of the things you're going to all help yourselves with is if you don't see a numerical coefficient class, you know it is a 1, right in the 1. Now, does this 3b cubed have any friends, Ben?
The 1b.
The 1b cubed. So let's combine those. 3b cubed plus another 1b cubed.
4.
4b cubed. Again, don't think of that as a 0b cubed. It's not 3 plus nothing is 3. 3 plus 1, but we need to write it in, is 4. Does the 4b squared have any friends?
No.
No, but he still exists, so we should write down
4b squared.
positive 4b squared. Does the negative 9b have any friends?
That's
But he still exists, so we should also write down.
negative 9b.
Class, what order are these terms written in?
Descending.
Descending order. It's one of our conventional orders, alphabetical order and descending order, where we have b cubed, b squared, b to the first. The powers of b are getting smaller. Anyone perfect on the 45 to 53? Anyone perfect on those? Anyone just miss 1 or 2? I've gone over several of them already. Any questions on the 45 to 53? Well, let's look at numbers 54 to 59. How would I write out p increased by 12? Joel?
P plus 12.
P plus 12. How about the quotient of m and 3? Griffin?
M divided by 3.
How do I show division?
Fraction bar
So we could also say m
over
3. Though it's not wrong if you write it m divided by 3 like that. That's not wrong. It's just better to write m over 3. Number 56, the ratio of w to k. Corey?
W over K.
W over k. 7 less than x. Elaine?
X minus 7.
Great job. The than tells me to flip it, so x minus 7. Number 58, r less than 3. Kirsten?
3 negative R.
3 negative r, or 3 minus r, but I like this, he said 3 negative r. Good, we have to flip it again because it says less than. 2 more than twice g. Michael?
G squared raised to 2.
What does more than mean? Obviously the than means flip, and you did flip, but what does more than mean?
Add.
Add. So we're not going to multiply the 2. What does it mean if we say twice g? If I said I'm twice your height, which I'm not, but if I were twice your height, that would mean I do what?
Multiply by 2.
Multiply by 2. Not multiply your height by itself, but multiply by 2. So not g squared, but
G times 2.
there we go, or 2g. So 2g plus 2 would be 2 more than twice g. How many got all 6 of those correct? Anyone just miss 1? Any questions on the ones we may have missed? All right. We'll take a look at more of that in your homework tonight. We'll review a little bit more over it tomorrow. Though at this point, we should have it down pretty well. I want to review some things with you that you actually saw in a recent speed drill. If you go back in your mind to speed drill 160, it was all about powers and exponents. Things like 5 cubed or 2 to the 5th and things like that. Well, plus, when I say a 5 cubed, what does that literally mean? 5 times 5 times 5. Or if I see a 2 to the 5th, class, that literally means?
2 times 2 times 2 times 2 times 2.
All right, so at your seats real quick, what would 5 cubed equal?
1 and
Wow, some of you really fast, 125. All right, let's see if we're equally fast on 2 to the 5th. What would that equal?
32.
32. There we go. And again, you multiply it out. And so we're familiar with some terminology here. This value here, or this value here, the 2 or the 5 in this case class, those are referred to as the base in each case. And the little numbers are called the exponents. Well, if we were to raise something to a particular power, we have, for instance, if we were to square something, like for instance, class, we square a 1, of course, we would get 1. If we were to square a 2, we would get 4. These numbers like 1 and 4, or if I squared a 3, class, I would get 9. Numbers like 1, 4, and 9 are referred to as perfect squares. Perfect squares. Because they are the result of squaring an integer, or a nice, easy number. A number like 125 is called a perfect cube. It's the result of cubing something. 32 would be considered a perfect fifth, because it's the result of raising something to the 5th power. But there are numbers out there that aren't perfect squares, or perfect cubes, right? For instance, if 1 squared is 1, 2 squared is 4, 3 squared is 9, what squared would equal 6? Nothing. At least not a nice, easy number. 6 would not be considered a perfect square. Does that make sense? I want to look at this idea of perfect squares or perfect cubes. Turn over to page 431. Turn over to page 431. And we see in that first little paragraph there the term perfect square. Perfect square is a number or variable that's the product of 2 identical rational factors. They say that 25 is a perfect square. Well, why is 25 a perfect square, class? Because you could square a 5 to get it. Can someone raise your hand and think of another perfect square besides 1, 4, 9, or 25? Jalen?
6 squared.
Well, what is that? 36. So 36 would be a perfect square. Give me another perfect square, Joel.
64.
64 is a perfect square. How about you, Luciana?
250.
What would you square to get 250?
Wait, never mind.
Bryson?
49.
49 would be a perfect square. Try again, Jalen.
4.
Well, 4 is already on the board.
Oh, no, 16.
16 would be a perfect square. Michael?
81.
81's a perfect square. Elaine?
144.
144 is a perfect square. There's only a few that we haven't gotten so far. You remember?
121.
121's a perfect square. I'm thinking of at least one more we should know. 100 is the one I was thinking of, and I think we got all the ones we should have memorized by now. We also see this, a perfect cube. See that term? A perfect cube is a number or variable that's the product of 3 identical rational factors. 8, for instance, it says is a perfect cube because 2 times 2 times 2 is a perfect cube, 8. Okay? Flip over, if you would, to page 433 now. Flip over, if you would, to page 433. And notice they've started a little chart here. 1, and they show 1 squared is 1, and then they show 1 cubed is 1. And then they go to 2. Well, we can write in, we know what 2 squared is, class. 4. And 2 cubed would be another 2 multiplied by that 4 to get 8. All right, let's continue the chart. For number 3, 3 squared, class, is 9. We're filling in the chart then. Pick up your pencil and stay with me, please. Stay focused. No, it's a Monday morning. Let's force ourselves to pay attention and finish. Well, just 4 more weeks. Is that crazy to think about? Just 4 more weeks. We are almost done with 7th grade. Yeah, crazy to think about. And technically just under 4 more weeks, but anyway, I digress. Anyway, 3 cubed. What would that be? 3 times 3 times 3. 27, because 3 squared is the 9, then multiply another 3 to get your 27. What about 4 squared? 16, then multiply another 4 to get the cube. 64. All right. 5 squared, of course, class. 25, and we just put 5 cubed on the board a moment ago. 125. Now we're going to get into the harder ones. Now the squares are still going to be easy for us. 6 squared, class. 36, and then the cube.
182.
216. There we go, Luciana, with the win. 216 is our 6 cubed. All right, 7 squared, class. We know that?
49.
49. Okay, and now the cube of the 49. 343. I think she worked ahead. 343. She smiles. Yeah. All right. 8 squared, class.
64.
64. Okay. Now the cube.
512.
512
Right.
is correct. All right. 9 squared, of course, class is
81.
81. Someone other than Elaine, the cube of 9 would be
729.
720. That was actually easier to do in your head, isn't it? Because 9 times 1 and then 9 times 8. So you didn't have to carry anything. Makes it a little easier on that one. 10 squared, class. 100. We should all know that. And then 10 cubed, 1,000. Multiply that 100 by 10. Just picture 10 $100 bills. That's a nice thought. Anyway, not that we love money, just like it a lot. Anyway, number 11. 11 squared, class. 121. 11 cubed. Take a moment.
1,331.
Some of you cheating working ahead there. 1,331, but you're not wrong. 1,331 is 11 cubed. How about 12 squared, class? 144. We should all know that. And then 12 cubed.
1,728.
My worker aheader's got it. 1,720. We'll just all kind of, ride their coattails there and
Fun.
benefit from their
Fun copying.
getting it. All right, our camera's being weird, but I think we're still rolling here. All right, then we come to some letters. Whoa, letters. Oh, Mr. Dasky, W, and we have to square it. Well, W, if you square it, means W times W, right? Well, what is that, class? W squared. Okay, and then if you cube it, that means you multiply another W. What do you get? W cubed. Yeah. So the square of W is W squared. The cube of W is W cubed. That's not too hard. Okay. How about if we square a Y? Y squared. What if we cube a Y? Y cubed. Yeah. How about if we square an X? X squared. What about if we cube the X? X cubed. Yeah. How about if we square a D? D squared. What if we cube a D? D cubed. Not DQ. That's Dairy Queen. Okay. D cubed. And they're not sponsoring the YouTube channel. So, anyway. All right. So, we all understand the idea of what a perfect square is. Let's read through our perfect squares together. 1, 4, 9, 16, 25, 36, 49, 64, 81, 1,000, 121, 144. We'll stop there because the letters are ridiculous.
Why'd you say 1,000?
Did I say 1,000?
Yeah.
100. I was just saying if you were paying attention. That was supposed to be 100.
Yeah.
All right.
Yeah.
Now, those are all numbers we should be familiar with, right? The cubes we're a little less familiar with, and we don't have to memorize these or anything, but let's read through our cubes anyway, class. 1, 8, 27, 64, 125, 216, 343, 512, 729, 1,000, 1,331, 1,728. And we see all these squares, we see all these cubes. Well, for every process in mathematics that we have, there's always an inverse, right? Addition has an inverse of subtraction, right? Multiplication has an inverse of division. Well, so raising to a power, squaring something, cubing something has an inverse as well. And it's called a root. Turn back, if you would, to page 431. Turn back to page 431. So just flip back a page. And we're going to talk a little bit about roots. The first thing you see is this funny looking symbol. It almost looks like a division house, but it's got this little hook thingy on the front of it, okay? This is called a radical sign or a radical symbol. Notice that term. I use radical sign because it's a syllable less. A radical sign or radical symbol, that's the symbol that tells you we're taking a root. Question? Just sit tight for a minute. This is called a radical sign. Tells you that you're taking a root. And a root is the opposite of a power. If you'd write that off to the side margin of your book, the root is the opposite of a power. A root is the opposite of a power. So if I can square a 5, class, to get 25, I should be able to take a root of 25 and go back to the 5 I started with. Does that make sense? And the way we'll take a root is we'll simply write that little radical sign over the 25. And that means we want the square root of the 25. And that gives us back the 5. Does that make sense? How many learned this in 6th grade? We're familiar with this radical sign. Now, if I were to cube a 5, class, we said 5 cubed is 125. So I put the little radical symbol, and wait a second. Technically, if all you see is the radical symbol, it means a square root. How would I show I want a cube root? Well, I need to write a little 3 right here up against the radical sign. This little number here, we could make it anything. I'll make it a 6 just to be different. This number here is called the index. The index tells which root you want. The index tells which root you want. Mark that there in your book. The index tells you which root you want. In this case, a 6th root. In this case, a cube root. What if you don't see an index? Write this off to the side. If you don't see an index, it's an understood 2. If you don't see an index, it's an understood 2. Why? Well, because you would never take a first root. What would be the point of a first root? Right? What to the first gives 17? 17. So the first root of 17 is 7. Like, there's no point in taking a first root. Of course, you're just going to get what you already had. So the most basic root is the 2, the second root, and mathematicians are lazy. And most of the time when you take a root, most roots you'll take in your life will be square roots anyway. So mathematicians just say, look, we didn't want to write all these 2's. Let's just assume it's a 2. Let's assume it's a square root, unless we specify with a 3 for a cube root or a 6, heaven forbid, for a 6th root or something like that. And then the number that's inside, the number you're taking the root of, it's called the radicand. The radicand. Not the radicant, okay, the radicand. A student one time, a radicant, I said, yes, you can. Anyway, the radicand. For instance, maybe I wanted to take the 6th root of 64. Well, what you're asking then is, what times itself 6 times gives us 64? Any guesses?
2.
2. Times 2 times 2 times 2 times 2 times 2. If you multiply that out, 6 2's gives you 64. So therefore, the 6th root of 64 is 2. That's what you're asking. What times itself? So then, if we've got all of those squares written out, if we've got all those cubes written out, you realize we could take square roots and cube roots off of that. Flip back again real quick. I could ask you, what is the square root of 49, class? And we would know it's 7. Back to page 433, where we wrote up the little chart, the page we were just on a second ago. Yeah, the square root of 49 would equal 7. What about the square root of 121, class? 11. What about the square root of 25? 5. What about the cube root of 64? Well, you'd have to look in the cube column, wouldn't you, and find the 64. What was cubed to give me a 64? A 4. So therefore, the cube root of 64, class, must be 4. Notice the way in which you read it. Listen, the cube root of 64. Okay, the cube root of 64. So if I wrote this expression here, well, we know what the answer is, class. 12. How would I read this, what we call radical expression? How would we read that, Corey?
144. Wait.
The square root of 144. How would you say it?
Square root of 144.
Class, say that with me. The square root of 144. What if I wrote this expression here? How would I read this expression, Bryson? The square root of 81. Of course, the square root of 81, class, is 9. How would I read this expression? How would I read this expression, Griffin?
The third of 260.
The third, well, we would say cube, but the cube, what's that word?
Cube of 200.
Not the cube of, the cube, class,
Square.
root. The cube root. This symbol, this radical sign, literally means, we'll read it with the word root. Now, not like the square roots or cubed roots that you see on the little picture at the bottom of page, what is that, 432? Yeah, not like those kind of roots, okay? That's not what we mean by square roots, okay? We're not talking about roots that have grown in squares. Also, there's all kinds of interesting things that have been buried over the years. Somebody is missing their car keys. But anyway, I digress. And the baseball. That's where it went. Anyway. Somebody hit it really high and so it sunk really deep, like a meteor. Anyway, so back to Griffin then. Griffin, how would I read this expression again?
The cube root of 216.
There we go, the cube root of 216. In class, you look at the chart, what is the cube root of 216?
6.
6. What about this expression? How would I read this? Ben?
3 cubed root 7
Of
729.
Good, the cube root of 729. In classes, you look at the chart, what is the cube root of 729?
9.
9. Do we understand how to read these roots? We understand what they mean. What is this little root symbol called, class? We read it with the word root, but it's actually called a radical sign. What is it, class? Radical sign. The little number right here, even if it's an understood 2, and of course you could write the 2 if you wanted to, I'm just lazy and don't want to, but this little number, class, is called the index. It's what it is to a root what the exponent is to a power. Does that make sense? Exponent raises to a power, this tells which root we're taking. And then this value inside the radical sign that I'm actually taking the root of. I take the square root of 81, the cube root of 216, cube root of 729. The number you're taking the root of, class, is called the radicand. What is it? Radicand. Look at page 433. Page 433, number 17. First of all, how would I read that expression? Luciana?
3 cubed 27.
Try that again.
Wait, no.
Remember that little radical symbol, we have to read the word root.
Cube root 27.
Of 27, the cube root of 27. Now, class, that little 3 that we see is called the index, and the 27 is called the radicand. And what the cube root of 27, class, from our chart would be? It would equal 3. Number 18, how would we read that radical? Elaine?
The square root of 121.
The square root of 121. Class, the 121 is called the radicand. And what is the index, Elaine?
2.
It's a 2. It's an understood 2, so we don't see it. Number 19, how would we read that expression, Jalen?
The 6th power of...
Not 6th power,
Oh,
the
okay.
6th
The 6th of
root. There we go.
64.
The 6th root of 64. The little 6 class is called the
Index.
index, and the 64 is called the radicand. How about, by the way, the 6th root of 64 class we already said is what?
2.
2. For the previous one, the square root of 121 would be
2.
11.
11. All right, the next one. How would we read number 20, Kirsten?
The 4th root of 625.
The 4th root of 625. Good. And what is the index there, Kirsten?
4.
4. And what do we call the 625?
The radicand.
The radicand. Any what guesses as to what the 4th root of 625 would be?
3. I just took a guess.
It ends in a 5, so that's a clue, right?
25.
15.
Well, the square root is actually 25. The 4th root would be 5. So 5 times 5 times 5, that's 125, times another 5 would be 625. You don't have to know that. It's okay. Look at the next one. Oh, my goodness. I don't know the answer to this one either. But how would we read number 21, Michael?
The 9th root of 26.
Don't you give up.
262,144.
We are not going to tell what the answer is because I don't know either. I'm not looking it up. But you're right. The 9th root of 262,144, the 262,144 class is called the radicand, and the 9 is called the index. Michael?
Correct. Can't do this one.
All right, number 12. Or 22, excuse me. The answer is 12. But number 22, how would we read that, Joel?
Square root of 144.
Good, the square root of 144, where your radicand class is 144, and the index is the understood 2. Do numbers 23 to 30. Do 23 to 30. Do numbers 23 to 30. Fill in the missing portion. For number 23, they ask the square root of what is 6? Well, that would have to be, Corey, the square root of 36. Very good. For number 24, the square root of what gives 9? Ben?
81.
81. Number 25, the square root of what gives 2? Kirsten? 4. Number 26, what is the square root of 144, Bryson?
12.
And number 27, what is, that was 12. The square root of 121 is what, Elaine?
11.
11. Number 28, the square root of 1 would equal what, Luciana?
1.
1. Number 29, the square root of what would equal x? What would we have to take the square root of to get x? Joel?
X squared.
You'd have to have an x squared. How many figured out that it's an x squared you would take the square root of to get x? Again, the way you think of it is, well, what would have to be multiplied by itself to get x? Well, x would have to be multiplied by itself, and that is x squared. So similarly on number 30, the square root of what would give p? Griffin?
E squared.
P squared. Now, I didn't ask you to do 31. This is an interesting problem. The square root of what gives b to the 4th? This is something we'll go over more in 8th grade next year. But, well, in order to get this, you would have to multiply b to the 4th times another b to the 4th, right? Well, what does b to the 4th actually mean, class? B times b times b times b, right? So this means I'd have to multiply b times another b. Well, what is that, class?
B to
B to the
b to the 8th power. That'd be b to the 8th power. I mean, that's a little bit more, and that's pre-algebra level stuff, so you don't have to know that yet, but there we go. Questions on that? Now, there are numbers that, as we said, are perfect squares. We can take the square root of them, they work out evenly. There's a whole bunch of numbers that are not perfect squares that don't work out evenly. And in fact, if you try to take the square roots of these numbers, they become decimals that never end and never repeat. We talked about that earlier this year. What do we call a number whose decimal never ends and also never repeats? There was a term for it. Do you remember?
I want to say pi.
Pi is an example of this. Pi is an example of this number because pi never ends or repeats. You can cheat and look further up on the page. It's actually at the very top of the page. What's that word, class? Irrational. Irrational numbers never end, never repeat. So for instance, the square root of 2, the square root of 3. Not the square root of 4. That's rational. This 4 is a perfect square. The square root of 5, the square root of 6, the square root of 7, the square root of 8. Not the square root of 9, because 9 is a perfect square. Square root of 10, square root of 11, square root of 12, square root of 30, square root. You get the idea. Most of the roots actually are not rational. They're irrational. And so I've got a little chart for you here. For those watching on YouTube, bless you, you see a link to this document here. Take one past the rest back. I've got a little table of squares, and we're going to play around with this here. You don't have to memorize these, so don't panic over this. But you've got a little table here of squares, and pass the rest back. I gave you one too many. All right. A little table of squares and square roots. And let's look over this table for a moment here together. As you look down the list, look at this number, and you see how 2 spaces later it has a square root. Notice 1, its square root comes out evenly to 1. You go down to 4, its square root comes out evenly to 2. 9, of course, comes out evenly to 3. All the way up to find 144 on the chart. Find 144. It's here on the third, bless you, grouping of columns. And of course, you see its square root, class, comes out evenly to 12. Now, find the next square. Find the next perfect square on the chart. Its square root will be even.
200.
200 square root doesn't come out evenly. 200 square root is 14.142, but Michael says 196, look at it, class, 14.000. It comes out evenly. So 196 is a perfect square. There's another one, though, that he skipped over, Jalen. 169. You see 169 has as its square root a nice perfect 13. Now, you could work it this way if we wanted to go through. We could find our roots this way, or we could go a different route. Look down the very second column. You see how we have squares? 1, 4, 9, 16, 25. Do you see how 169 and 196 are right here on the list? But the next number is 225. Well, that's the square class of 15. And then 256 is the square of 16. So if I wanted to know, for instance, what is the square root of 289? Well, right here, 289 is the square class of 17. So therefore, the square root of 289 must be 17. Does that make sense? Let's go a little further down the list. What is the square root of 841? 29. What is 29's square root? And it's not rational, is it? What is 29's square root? Approximately 5.385. Do you see how we can use the list a couple different directions? So if I wanted to know what's the square root of, I don't know, let's say 150. Well, we're going to have to find 150 as the bold number on the list. It's actually the very bottom of the third column. What is 150's approximate square root, class?
12.247.
Does everyone see the 12.247? That's the square root of 150, because it doesn't come out evenly. But you know, we could also guesstimate square roots, couldn't we? For instance, I know the square root of 144, class, is what? 12. But the square root of 150, that's only a little bit bigger than 144, isn't it? So it makes sense, doesn't it, that it would be a little bit bigger than 12, maybe somewhere around 12.2, or in this case, 12.247. So if I were to say the square root of 81, well, class, we know the square root of 81 is 9. Okay, without looking at the chart, what would be approximately the square root of 79? Don't look at the chart. 79 would have to have a square root somewhere around what?
8.9.
8.8, 8.9, something like that. All right, now look at the chart. Find 79 as the bold number. What is 79's square root?
8.8.
Now, it looks like a repeating decimal. It doesn't actually keep repeating with 8s, okay? It is irrational. But yeah, it's about 8.8, 8.9. In fact, y'all were actually closer when you said 8.9, because that's what it would round to, wouldn't it? What if we said the square root of 36? What's that, class? 6. Okay, without looking at the chart, what would be the square root of 39, approximately? 6.3-ish. Let's just guesstimate 6.3. Now look at the chart. What is 39's actual square root, at least to 3 digits?
6.245.
Okay, so it's actually closer to 6.2 after all, but 6.245. Do you get the idea how you could guesstimate, even if you don't know exactly what it is, you could kind of guesstimate what a square root would be. Without looking at the chart, how about a square root of 72? That's not rational, is it? But it's between the square roots of 64, which is 8, and the square root of 81, which is 9. It's right between the 64 and 81, which we know this is 8, we know this is 9, so therefore square root of 72 would be around 8.5-ish. Okay, now let's look it up on a chart. What is the square root of 72?
8.485.
8.485. Does that make sense? Okay, so that we can guesstimate square roots without actually looking them up, but we could look them up as well. We could also, like I say, cheat off the list, and we could get some square roots of some really big numbers. Right? If I asked what's the square root of 40,000? Well, what was squared on the chart at the very end to give me 40,000, class? 200. So we know the square root of 40,000 is 200. What if I asked for the square root of 29,929? We look up the chart and we find this number there, and it's 173, right? So we can look up some really big square roots from this chart. We can look up the smaller square roots from this chart. This gives us a little bit of access there to some different numbers. Got another handout for those watching on YouTube. Again, it's going to be in the description of the video. Let's use this chart for some of these. Some of these we won't need the chart. Some of these we will. But let's look up some of these together here. Now the top section, you can set the chart aside and do the top section just from things you've already memorized. Do the top section, forget the chart, just do this off stuff you've memorized already in your younger years. Take about a minute and a half, if that.
Bless you.
Look.
A little reminiscent of some speed drills we've done. The top section, at least.
Just top right now.
Just the very top section. That's all we're doing right now. All right, Luciana, square root of 81.
9.
9. Corey, 8 squared.
64.
64. Ben, square root of 36.
6.
6. Joel, square root of 9. 3. 5 squared. Griffin.
25.
25. Square root of 16. Kirsten.
4.
4. Square root of 4. Jalen. 2. 7 squared. Elaine.
49.
49. Luciana, 12 squared.
144.
144. And square root of 121. Ben.
11.
11. Now the next set of problems, these ones, these aren't necessarily memorized values. Look at the next row. They start us off, class, with -2 cubed. And it says to write out each of the following and simplify. So write out means write out what -2 cubed literally means. Griffin?
Wait.
What does it mean to cube a -2?
-2 times -2 times -2.
There we go. So go ahead and write that out there on your paper. -2 times -2 times -2. Stay with me. Now, remember when we multiply, we said we're going to count how many negatives we have. Class, we obviously have how many negatives? 3. We said if it's an even number of negatives, we're going to get a positive. But in this case, since it's an odd number of negatives, class, we're going to get a negative. And then multiply 2 times 2 times 2 to get 8. So our answer ends up being here a -8. Does that make sense? You finish out that row. You finish out the row, write it out first, then simplify. Write it out, then multiply to find the answer for that second row of problems on the handout. Several people finishing up. Take just a little longer. Write it out and then figure it out. All right, for the next one, it says 5 to the 4th. I trust that you wrote 5 times 5 times 5 times 5. And what did you get for your answer, Elaine?
625.
625. How many had that answer? Looking at the next one, hopefully for -10 squared, you wrote out -10 times -10. But what was your answer for this one, Kirsten?
Positive 100.
It is positive 100. How many had positive 100 here? Because there's two negatives. Negative times negative gives positive. Looking at the next one, 4 cubed. Well, hopefully you wrote out 4 times 4 times 4. What did you get when you multiplied it, Joel? 64 is correct. And then for the last one on this row, it was a -3 to the 4th power. And so hopefully you wrote out -3 times -3 times -3 times -3. And Corey, what did we get for our answer?
81.
It is a positive 81 or just 81. Good, you don't have to write the positive. How many got all 4 of those correct on that row? All right, so we understand how to raise to the powers then. Yes, ma'am.
What did 64 be a negative?
Well, if this were a -4 cubed, then yes, because then we'd have 1, 2, 3 negatives. But this isn't a -4, it's just a 4. Right? So we didn't say -4, so I don't have any negatives. There's no negatives to worry about at all. So positive times positive times positive, like, it's just still positive. Great question. Yeah, so just because there's an odd exponent doesn't necessarily mean it's going to be negative, only if it were a negative with the odd exponent. That combination ends up giving you the negative. Great question. Good. Other questions? All right, now we're going to go back to this little chart that we're using here, and let's go ahead and fill out that next section, the square root of 17. Well, find the 17 in bold, find its square root, and jot it down. And what should we write down for our first answer in that next section? Luciana?
4.123.
And of course, we knew it would be a little bit bigger than 4, didn't we? Because the square root of 16 is 4. Square root of 17 is going to be a tiny bit bigger than 4. How about 92 squared? Well, I ain't multiplying 92 times 92, not if I got a cheat sheet, right? So what do we get when we square the 92, Jalen?
8,464.
Good, 8,464. You find the 92 toward the bottom of the second bold column, and there's your 8,464. Do we see how to finish out this section? All right, use the handout to find the answers. You're not doing any math, you're just finding answers on the cheat sheet. Finish the section, finding answers on the cheat sheet. All right, let's take a look at this together. What do we get for the square root of 142? Corey?
11.9.
11.916?
Yeah.
Yeah, be sure to write out all the digits that are on the sheet there. 11.916. By the way, square root of 144 is 12, right? So we knew it would have to be just a tiny touch under 12, didn't we? How about the square root of 169, Joel? 13. How about 27 squared, Ben? The last one on that row.
729.
Good, follow along with me. 729 is correct. How about 33 squared, Elaine?
1,089.
Good, 1,089 squared to 97, Kirsten.
9.849.
And of course, the square root of 100 is 10. It's a little smaller than that, just a touch under 100. How about the square root of 82, Bryson?
6.724.
For square root of 82.
Oh, my fault. 9.055.
Yeah, 9.055 should have been correct there. How about 19 squared then, Bryson? What'd you get for the next one? 19 squared.
361.
361. Let me come back to you again for the square root of 50.
7.071.
Good, okay, just making sure we're reading the chart correctly. Square root of 196, Griffin.
14.
14. 40 squared. Might have been able to do that in our head without the chart. Luciana?
1,600.
1,600. Square root of 118, Corey.
10.863.
10.863, which again, it's a little smaller than square root of 121, which is 11, so it's a little smaller than 11. Square root of 63, what do we have, Ben?
7.937.
7.9, is it 3? Maybe I've got it written down incorrectly. It is 3.7, I'm dyslexic, I wrote 7.3. Let me edit that on my paper. 7.937, stay with me. And then 145 squared, really big number here. Kirsten?
21,025.
21,025. Let's do this next section together very quickly. What is the square root of 19,044? Then put it away. We're looking at the square column. Find the big number, 19,044. Now I'm asking for the square root of it, which means we're asking what was squared to get it. Class?
138.
138. Write that down. How about the square root of 6,724. The square root of 6,724, class?
82.
82. The square root of 32,400.
180.
180. Square root of 12,544.
112.
112. Right? Do we see how to use the chart in that direction? Last section, very quickly together. Yes or no, is the square root of 36 6?
Yes.
Yes, okay, so we'll leave it alone. Is 5 squared 10?
No.
No. Cross it out, put
25.
25. Is the square root of 79 6,241? Does that sound right?
No.
That sounds way wrong, right? What should it be? Look it up on the chart.
8.8.
8.888. Yeah, so let's cross that up at 8.888. How about for the next one? Square root of 40. Would that be a 20? Does that sound right? No. What should it be?
6.2325.
Yeah, we look it up on the chart, 6.325. Bottom row, last section, last part now. 9 cubed. Would that be a 27?
No.
No. For that, we almost might want to look back at that page 433. What is 9 cubed? 729. Because that means 9 times 9 times 9, not 9 times 3. How about the square root of 1,764? Would that be a 6.481?
Yes.
No.
Oh, does that sound right? The square root of 1,764, if you multiply it 6 times itself? No.
42.
42. 6.481 is the square root of the 42, not the square root of the 1,764. Does that make sense? Do you read that now? Right, so the 1764's square root is the 42, because 42 squared is 1,764. 42's square root is 6.481. How about 10 cubed? Would that be 1,000?
Yes.
Yeah. How about 49 square root? Would that be 9?
No.
What would that be?
7.
7. Do we feel like we understand the concept of squares and square roots? All right, you can keep this handout. If you'll pass the charts forward, I'm going to go ahead and collect those back from you. Pass the charts forward. Your homework for this evening. Homework for this evening is to do page 429. You keep that. Page 429. Do numbers 1 through 15. Page 429, do numbers 1 through 15. And page 436, do numbers 1 through 18. Page 436, do numbers 1 through 18. Then we're going to have a test coming up on Wednesday in lesson 163. Again, page 429, do 1 through 15. Page 436, do 1 through 18. Tomorrow, we'll wrap this up, review over our graphing, review over this little bit of algebra we've gone over, test on Wednesday. Have a wonderful rest of your day, and you are dismissed.